Hello, my name's Matt Wood. I'm very sorry that I can't join you at the conference today, and many thanks to Juliana for giving me the opportunity to present to you with a recorded presentation. Now, I understand that later you're going out for a beer, and I'm the last speaker of the day, so I'll try not to take too long. Today's talk, what I'm going to talk to you about is to try and address one of the challenges of surveying, censusing, burrow nesting procellariforms. So my work's been mostly on storm petrels and Manx shearwaters, and we've been doing some work to try and improve the repeatability of surveys so that they're of more conservation value. So I'm sure, as you know, seabirds are excellent study species. They are, excellent indicators of marine ecosystem health, and they're long-lived colony nesting species that are philopatric. They come back to the same place each year as breeders, and of course they're generally awesome animals to be able to study and often in very spectacular places. And some scientists, some people who study procellariforms in these spectacular places have got it easier than others. Some species are really quite easy to monitor. Some, on the other hand, are really more challenging to survey. So this is a typical view of a breeding colony of nocturnal burrow nesting procellariforms in the northeast Atlantic. If you're lucky, you might hear species like Manx shearwaters calling. We are Manx shearwaters, one of the main study species, and if you're really lucky, there might be something like a European storm petrel around. But one of the main difficulties with these species is that they're not visible, they're not easily visible, they are nesting under the ground, and some of them, in particular European storm petrels, are really prone to disturbance. So if we try to get too close to them, then it's generally going to be bad news, and we won't be able to monitor them in that state of being relatively undisturbed, and we'll get biased parameters. So essentially the question that I'm asking is how to count invisible seabirds, and I'm sure some of you will be familiar with this method. Our fieldwork takes place in Wales in the UK here, so there's the UK still geographically attached to Europe. And here's Wales on this very southwest coast. Off the tip of this part of Wales that I think looks like the head of a triceratops there are the islands of Skoma and Skocum. So how do we carry out these censuses of these burrow nesting species? Well, we take the benefit of the fact that if we play their call to an apparently occupied burrow, we'll get a response in a certain proportion of the time. Not always, but we'll usually get a response. So the first step is to identify the suitable habitat. Then we need to find some areas, some known occupied burrows. So if this is possible, we'll do it by checking inside the burrows, for example, to see if they have laid an egg. And then during the incubation period, we'll carry out these 10 visits to about 100 burrows if we can, and we do that playback to all 100 burrows 10 times with 10 different visits. And on average in our study system, so say it's not unusual for 40% of Manx shearwaters to respond. We play a duet tape of the males and the females to increase the response rate, and that helps as well. So being able to work out this response rate to playback is really important, because when we then go on to do single visits of playback survey to our suitable areas of habitat, then if we get, say, 20 responses in this particular plot that our field workers are doing here, if we have 20 responses, then we know that if that's only 40% of the birds, we can scale that up to the actual number of birds in that census plot, that survey plot. Then we do some interesting but quite slightly complicated mathematics, and then you'll be able to calculate your population size. And on this case for Skoma Island in 2018, we worked out that there's approximately 350,000 breeding pairs, so apparently occupied sites on Skomer Island, mostly gathered around particularly dense areas that have got deeper soil and plenty of space for new shearwater burrows in other parts of the island. So this might seem fine, but it has some drawbacks, this approach. It's quite mathematically complex to take the survey data and to then repeat those analyses in different surveys, either in the same place in different years or to go to different locations to be able to repeat the census. And so that's also led to the tendency for people to try and tweak the methods a little bit as over time. So we can have situations where methods are inconsistent and therefore not so comparable between different sites or different times. A further drawback is that there are no reliable error estimates for the overall calculation of population size. So there are basically some barriers that hinder the development of this technique so that it can be adopted more widely. Procellariforms are a conservation priority in the UK. They have a restricted range. They have quite poor geographical survey coverage. There are lots of places in the northwest of Scotland, for example, that are not well surveyed. They nest in quite challenging locations. If we extend the scope to include the Republic of Ireland as well, then there's wide areas on the west coast of Ireland that are not well surveyed at all. And so we've got lots of uncertainty in our population estimates. So Manx shearwaters are amber listed. They have large population sizes, but only in a few locations. European storm petrels are amber listed as well, partly because of a lack of data, partly because of the restricted geographical distribution. And Leach's storm petrels there, I think my face is covering it up a little, are actually red listed because of rapid population declines in the St Kilda archipelago. So it's very important that we can develop methods as best we can to address this data gap. So how did we approach this? This is what we're trying to achieve, is to tackle this data gap in burrowing procellariforms in the UK. And we took two main approaches. We developed a playback census planning guidebook, and then we've also worked on some data analysis apps to encourage people to use these different approaches as well. I'm going to talk about these two things for you briefly now. All these planning guidebooks and the data analysis apps are available on this Stormie Shiny apps website. It was developed when we were working on a census project on European storm petrels, and that's the nickname that we tend to give them in the UK. So if you visit this website, and I hope you will if it's your area of interest, you'll see that here's the website. And many thanks, of course, to Bart Verkruyser from the Petrels by Night project, who's helped us with lots of these incredible photographs, which I believe you'll be hearing some more from Bart at the conference. And it has these two options to look at: the planning guidance and the analysis platform as well. So the planning guidebook is the result of some work with Mark Bolton and Ollie Paget. So that's going to be available as a JNCC report from the UK. That'll be freely available. And it gives advice about how to tackle different species if you can access the nest or if you can't, or if you've got different habitat types on your island, as this multicoloured splodge here shows. In the data analysis apps, there's some advice on how to format your data so that whenever people are conducting these surveys, the data are being stored and archived in the same format. So I was talking earlier about making multiple visits, say 10 different visits to a number of nests, 1, 2, 3, 4, so that our data analysis apps can work. If you put your data in these formats, then it'll go very smoothly. And there are, in the data analysis app options, you can load your data file. You can then select some settings, calculate your response rate, to call playback, which is the very important part. It's the key to reliable census estimates using call playback. You have to cover the suitable habitat, of course, but a reliable estimate of response rate to call playback is really, really crucial. And then you can download the outputs and also incorporate combine these response rates and your survey data using some code that we've made available in R Markdown. So I'd recommend you visit the analysis website for more on that. And there are different analysis approaches. This is the old school method using the do-fer method, so that you can compare your census results with the way that it was being done previously. Now we've developed a new method to estimate response rate to increase the reliability of those calculations. So it uses a maximum likelihood framework. This is something that Ollie Paget developed, and also because it's the end of your day, I'm not going to talk about this for too long. But as you can imagine, as you have your plot of approximately 30 occupied storm petrel burrows, for example, each day you conduct some playback, you'll accumulate more and more responses until the number of new burrows that you detect over time starts to decline. Now, typically, surveyors would take this maximum number after 10 repeat visits as their number of responses from the burrows that they've got. But we found that we can use the shape, the mathematical shape of this curve to calculate the asymptote here, to be able to calculate the hypothetical number of response rates that you would get in that piece of habitat. So this asymptote, which typically is higher than the apparent number of responses, maximum responses down here, so actually it means that you would be overestimating your population size if you use this number. That's being the advance that we've made, and importantly, that response rate also has, with the dotted lines there, an estimate of the confidence interval around that estimated number of responses. So we can use that to be able to include error in our calculations, which is something that hasn't been done systematically before. So we've applied this new approach to reanalyze some existing census data, and we had some funding from Natural Resources Wales, an agency of the Welsh Government, who were obviously concerned about this apparent population decline. Previous censuses had taken place in 1970, in the mid 1990s and early 2000s, which showed a really worrying, precipitous decline. We reanalyzed these data using our framework, and you can see that these later censuses were pretty much spot on. We didn't have the data available for this one. It was done by a different method, and this is our 2016 census that we repeated. So it seems like, well, maybe there's not such a problem going on. But you'll remember, because we can introduce our error estimates here, we can now start to see that because these error bars all overlap, we can't make any conclusion about population change here. And in fact, the errors for 2016 were really, really small. I have plotted them. It's just that you can't see them behind the big yellow spot. So overall, we concluded that the population has been stable at least since 2000, I think. This census was quite a small sample, so we're not as sure about it. And that's an important advance that we've made, that perhaps we don't need to be as concerned about this one particular population as we were. So to conclude, we've improved our methods both in terms of the survey guidance and our analysis framework, and used that to refine our population estimates. And what we'd like to do next is encourage the use of this analysis platform so that we get wider census coverage, either over repeated numbers of surveys to detect change or a wider geographical scope. And now that we have this repeatable framework, we can use this to encourage more meaningful comparisons between surveys. With those data, we'll then have improved evidence base for assessment of potential threats. If you'd like to learn more about this analysis platform, the best way to find it is to Google Stormie Shiny apps, or you can email me there or contact me on Twitter. The details are down there. And that just remains to say thank you very much to all of our funders and for you for your attention, and cheers from England.